An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodeland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland megatsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano megatsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo megatsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The megatsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam megatsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The megatsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and is quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river, and depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap, and these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano. And in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island. And then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails.
Do you know that NASA explores not only stars, planets, galaxies, or black holes? Hard to believe, but yes. The agency also works on discoveries here on our home planet Earth. So what has NASA recently discovered? Is there life under the ice? While they were analyzing data recently, they discovered something unbelievable hiding under Antarctica's ice. And this discovery not only changes everything we know about the whole water system of the Earth, but it may also help with research about life in space. Humankind's existence might depend on understanding Antarctica and its secrets. So, the recent discoveries reveal vital information about our survival. But before we continue, let's see how much you know about this place, where it's only ice as far as your eyes can see. Antarctica is one of the world's 7 continents in the southern hemisphere. It's the 5th largest continent in terms of total area, and that means it's almost twice the size of Australia. Want to see real meteorites? Go to Antarctica. Due to its dry climate, Antarctica is one of the best places to observe space. But what's even greater is that you can find meteorites on the white surface of the continent. Scientists have already plucked about 45,000 meteorites from the ice, and they think they can see another 300,000. Since there aren't many terrestrial rocks there, it's easy for them to spot them, thanks to their dark color. Antarctica's dry desert environment also helps preserve them, even the ones that fell to Earth more than 1 million years ago. And can you imagine any volcanic activity in Antarctica? It's hard. But this place is where fire meets the ice. West Antarctica is where most volcanic activity occurs. Scientists recently found that 138 volcanoes exist in West Antarctica alone. Wow! You would think that Antarctica is always cold, but no. Its coastal regions can get as warm as 50 degrees Fahrenheit. But have you ever wondered what Antarctica would look like if there were no ice? It may seem unimaginable now, but it was not always covered by ice. That was 34 million years ago, though, so nobody could tell how the continent's surface would be without the ice. But NASA changed that. They generated computer simulations and created the most accurate map of it as of today. What they saw was incredible. The continent was not flat at all like it seemed. It's pretty bumpy with valleys, rolling plains, and high mountains. But this was nothing next to what they had discovered under Antarctica's ice. So, what is it? Drum roll, please. NASA found 2 new subglacial lakes. And what's even cooler about it is that they spotted these lakes from space. How is that? If your answer is high-tech satellites, then you're right. In 2003, NASA launched a satellite called IceSat. It measured ice sheet mass balance and cloud and aerosol heights. The satellite also helped create the ice-free map of Antarctica. In 2010, the European Space Agency launched the second satellite, CryoSat-2. It was for tracking the changes in the thickness of the ice. Then, in 2018, NASA launched the third one, IceSat-2, a follow-on to the IceSat spacecraft. It measured ice sheet elevation and sea ice thickness. It was NASA's most advanced Earth-observing laser instrument. It delivered the highest precision data. And when that was combined with the data from the other satellites, it was possible to spot these 2 new lakes near a pair of larger ones. But how is it possible that these lakes exist in the first place? The average thickness of most Antarctica ice is approximately 1.2 miles. However, it can get over 1.8 miles thick in some places, especially during the winter. So, you might think that there's nothing under there, but science says otherwise. It's not quite possible to see it with your bare eyes, but the continent's ice is slowly but constantly flowing in different directions under the force of its weight. But scientists could not figure out how water moved for many years. That started to change in 2007, when data gathered from the IceSat provided insight into what hides beneath the surface. They first discovered an entire network of meltwater lakes connected under Antarctica's fast-flowing ice streams, and there were hundreds of them. Scripps Institution of Oceanography glaciologist Helen Amanda Fricker figured that the elevation changes measured by IceSat happened because of the dynamics of these lakes. They did not hold meltwater statically. Instead, they were filling and draining continuously over time through a system of waterways. And as they did that, the ice above rose and fell. But where do they drain? The ocean, of course, and it drains a lot. A recent study, co-authored by Fricker, found that the drainage of one lake flushed as much as 198 billion gallons into the ocean in only 3 days. Countless mysteries about how nature works are still waiting to be solved. But finding the 2 new lakes will give scientists a better picture of how fast the Antarctic ice sheet will change as the climate gets warmer, and how this will affect global ocean currents and sea level rise. The filling and draining cycle of the lakes also caused the ice sheet to suffer cracks and crevices. So, the information they find from these new lakes will also give them a better understanding of the damage on the surface of the ice. They will also be able to assess how this filling and draining system influences the speed at which ice slips into the oceans and seas. And that means they can evaluate how the added freshwater may alter marine ecosystems. This discovery may also suggest whether life is under the ice. Wow! Scientists drilled through about 3,504 feet of ice and found that water samples taken from one of the lakes contained approximately 10,000 bacterial cells per milliliter. Such a high number of bacterial life is a good sign, because that means the icy waters might also support higher life forms, such as microanimals, and one of these new lakes might even be their home. But the most exciting thing is that the new lakes might help them understand whether life on other planets is possible. Scientists believe any life below the frozen surface of the planet Mars might follow the patterns seen in Antarctica's lakes. So, there is a possibility that they might find critical new information on the type of life that may have existed on the red planet. You wouldn't want to be there during the winter, though. The lowest temperature on Earth you can experience is negative 128 degrees Fahrenheit. In 2010, there was an even lower temperature of negative 135 degrees Fahrenheit. And you may feel this cold much worse due to the strong and dry winds. Did you know that the size of the ice surface on Antarctica also changes throughout the year? It's about 1.2 million square miles during the summer, but when it's winter, it grows to 7.3 million square miles. Yet, despite the change, it remains the largest piece of ice on Earth. Sorry, Arctic, you lose. Do you know these cute little penguins? Consider these animals the locals because there is no native population in Antarctica. It's a no man's land because no single country owns it. But do you know who really owns it? 5 different species of penguins, seals, and killer whales. Ha. Despite the continent's harsh conditions, you can visit it as a tourist for fishing and research purposes. Around 5,000 people reside on the continent during summer at research stations. But when winter comes, the number naturally drops down to 1,000. Antarctica.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe.
Meet Hula Male, also known as the City of Hope. This nickname makes total sense since this artificial island is part of the Maldives' big plan to avoid being completely submerged in the near future. Hula Male was created by placing sand from the seafloor onto a submerged coral platform, and it worked. This city sits about 6 feet above sea level, which means it's twice as high as the Maldives' capital, Male. While more and more people are moving there to live, the island was also designed to serve as a temporary evacuation site during dangerous storms and typhoons. Seychelles is another gem in the Indian Ocean that's at risk of disappearing. Unfortunately, coastal flooding is becoming a common issue there, especially during spring tides and heavy rainfall. The problem is that their main island, Mahé, hosts about 90% of the country's population. Along the coast, it's only about 6 feet above sea level. Fiji is the third tropical paradise on our list, and it's also a top pick for travelers. But this nation is in a tough spot, since it's located right in the middle of the Pacific Ocean, where huge storms can really turn things into chaos. Take Cyclone Winston. It hit Fiji back in 2016 and ended up costing them over $1 billion in damage. So one thing they're doing to protect themselves is planting mangroves along the coast and preserving the ones that already exist. These trees are awesome since they help reduce wind speed during cyclone emergencies and also combat erosion by trapping sediments. Egypt might be in trouble too. I mean, it's not like the whole country is going to be underwater and we'll only see the tips of the pyramids in a few years. But things could really change for them as coastal cities are facing a serious risk. Take Alexandria, for instance. 45% of its population already lives below sea level. If the city is flooded, not only will everyone have to move, but Egypt in general will suffer a major impact on its fish production. In Europe, one of the most at-risk populations is in the Netherlands, where about half the people live in areas below sea level. In the future, planning a romantic gesture with tulips for your girlfriend could become an impossible mission. The Netherlands is responsible for 2/3 of the world's tulip production. So if fields are taken over by saltwater, it's game over for the blooms. But the good news is that the Dutch have centuries of experience dealing with water, so knowing how to work with storm barriers and seawalls can prevent them from a doomsday scenario. The risks of rising sea levels probably aren't higher anywhere else than here in Tuvalu. This island chain, located halfway between Australia and Hawaii, could be the first state to become uninhabitable. Its stunning land is only about 9 feet above sea level. And just by looking at it on the map, you can see how narrow it is. In fact, the narrowest part in Fongafale is only about 65 feet wide. So even before higher tides become a real problem, the country's limited farmland could be flooded with saltwater. The next country on our list is the Philippines. This archipelago in Southeast Asia boasts some of the most stunning scenery, but it faces the risk of flooding for 2 reasons. First, due to rising sea levels, and second, because of crazy, unpredictable weather. Since 1990, events like cyclones, earthquakes, and tsunamis have cost the country over $20 billion. Have you ever heard of Vanuatu? This chain of islands, spread out between Australia and Fiji, could be flooded soon. Vanuatu was one of the first Pacific nations to relocate an entire community to a safer spot. Back in 2005, residents living in risky coastal areas of the northern island of Tegua moved to higher ground. Next up, the Marshall Islands, a country located in the Central Pacific. Studies show that 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't throwing in the towel just yet. they've got a game plan. They are fortifying the infrastructures of their low-lying airport, relocating key buildings to higher ground, and putting up seawalls on rural islands. Heading south, we've got Nauru. This is actually one of the smallest countries in the world, covering just 8.1 square miles. Today, it's home to 10,000 people, but it's on the brink of becoming uninhabitable. Water levels are rising about 3 times faster there than the global average. The Buada Lagoon sparks special concern since it's the only surface freshwater resource, and it's located only 16 feet above sea level. Our next stop in the Pacific Ocean is the Republic of Palau. Rising sea levels are no joke for them either, but protecting their crops, especially taro, is a priority at this moment. About halfway between Hawaii and New Zealand lies Samoa, and this country is dealing with a unique situation. Not only is the volume of water increasing there, but their land is also sinking. You see, a couple of strong earthquakes and tsunamis hit Samoa back in 2009. So as the crust bounces back to its original position, the overall land surface is actually going down. Because of this, their housing and main infrastructure could take a serious hit, especially since all their airports are along the coast. Let's head to Kiribati. This Pacific nation has a big problem with frequent flooding because most of its people and infrastructure are near the coast. Apart from the volcanic island of Banaba, none of Kiribati's land is more than 6.5 feet above the ocean. To tackle this situation and keep their population safe, they had this big idea of making a massive floating platform, kind of like the ones oil companies have. But the problem is that it would cost them a fortune, as the project is estimated to be around $2 billion. If visiting Vietnam is on your bucket list, you better hurry up. The top 10 things to do there mostly involve cruising to jaw-dropping spots like down to Ha Long Bay, also known as the Descending Dragons Bay. But by 2050, the surrounding land over there might be underwater. Another huge problem Vietnam is facing is that the main rice fields are getting salty. And if you're into Vietnamese food, you know how important rice is for them. Right now, they're especially concerned about the Mekong Delta region being vulnerable. After all, this is a highly fertile area responsible for most of Vietnam's agricultural output, with over 50% of it being, rice. This nation is really putting in the effort to adjust to this new reality. They're flushing the rice fields in the Mekong Delta with fresh water to get rid of the saltiness. Our next stop is in the Caribbean Sea. Grenada is an island country, but you may know it as the Island of Spice since its tropical climate is just perfect for cultivating things like nutmeg, cinnamon, cloves, and ginger. Unfortunately, Grenada and its incredible fertile soil also face an uncertain future of being submerged. Let's talk about the last country on our list, the Solomon Islands. 5 islands in this archipelago have already vanished beneath the waves, and 6 others are submerged by 20%. They include the Nusa Evili Island, which was once a hotspot to go to for a picnic in the early 2000s. Even though the situation is complicated, it's important to note that more than 300 of the islands there are inhabited. One thing about the Solomon Islands is that it seems like they're always in some kind of recovery mode, since the country often gets hit by tropical cyclones and flash floods. Their population is already working hard to save their homes from the rising seas by building stone walls along the coast, planting mangroves, and constructing houses in higher areas.
Ah, Phoenix. This sizzling gem in the Sonoran Desert isn't just another American city. It's more like a giant oven where you can throw a party, as long as you don't forget the ice. Seriously, if you find yourself here in the summer, brace yourself for some serious heat. We're talking about temperatures that regularly pass 100 degrees. And in 2024, Phoenix hit 110 degrees 55 times during the summer, tying the record set just the year before. Now, I get it if you're not a fan of hot weather, but apparently a lot of people love living in a sauna. Phoenix ranks as the 5th largest city in the United States, And it is the capital and most populous city in Arizona, with 1.7 million residents as of 2024. And if we're talking about the metropolitan area, also known as the Valley of the Sun, the population is almost 5 million. Yet, good luck finding someone actually born here. Out of every 4 Phoenix residents, 3 were born somewhere else. Believe it or not, Phoenix wasn't always this bustling, crowded place. It became one. A few decades ago, it was just a sleepy little dot on the map. Back in the 1940s, the population was around 65,000. It wasn't even close to cracking the top 100 list of the largest U.S. cities. Now, at that time, Phoenix was mostly an agricultural hub, and its economy revolved around what they called the 5 C's: cotton, citrus, cattle, climate, and copper. But things really started to change in the 1950s thanks to one life-changing invention. Drumroll please? The air conditioner. Actually, it was the portable version that came out in 1945, created by an American inventor named Robert Sherman. Phoenix residents owe a lot to Robert for making life bearable during scorching summers. Before AC, people in Phoenix would literally move their beds outside and build sleeping porches. They'd protect that kind of outdoorsy space with light curtains or some kind of net to keep the dust and bugs out. Fun. Anyway, the point is that the air conditioner played a big part in making Phoenix an easier place to live. Since the 1940s, this city in Arizona has transformed from a dusty little town into a sprawling urban jungle, and it's still one of the top 10 fastest-growing metro areas in the U.S. The best part is, it looks like that won't change anytime soon, since this 519-square-mile metropolis is surrounded by rolling desert, with plenty of room to keep growing as far as the eye can see. So, who's dropping everything to move to Phoenix? Well, Californians are the city's biggest fans. According to a recent survey, a third of all new renters moving to Phoenix come from Los Angeles. Okay, that survey might not be the most reliable since it only applies to the source's clients, but it does line up with U.S. Census Bureau data from 2019, which says that 70,000 Californians moved to Arizona in the previous year. The connection between Phoenix and LA is so strong that some people even call Phoenix the next LA. You've got to give Phoenix credit for capitalizing on its proximity to Southern California. The city offers lower taxes, fewer regulations, and lower costs of living, which makes it a magnet for businesses, especially in high-tech and service industries. So, in the 90s, Phoenix was considered a non-stop generator of jobs. In the last few years, we've seen the number of jobs only go up, and the unemployment rate has dropped by nearly half, going from 6.3 in January 2014 to 3.4 in the same month in 2024. Now, when it comes to big city problems, you can't avoid talking about traffic. But here's another reason why Phoenix is a dream city. It doesn't even come close to the traffic nightmares you find in places like LA. Estimates show that people in Los Angeles waste about 119 hours a year just sitting in traffic. But in Phoenix, it's more like 61 hours. Huge difference, huh? And let's not even start talking about the money people waste just sitting in traffic. In LA, drivers burn through about $2,440 worth of gas per year. In Phoenix, they waste 25 gallons of fuel, which ends up costing about $952. Yeah, that's still a lot of cash, but compared to LA, come on, that's a steal. Phoenix being okay in terms of traffic might have a lot to do with how the city was designed. Just take a look at a map of Phoenix. You'll notice it looks like someone took a ruler and drew perfectly straight lines for the roads. That's because the city was laid out in a grid system. This setup makes it so much easier to get around, especially compared to cities full of confusing twists, U-turns, and one-way streets. It just simplifies things, whether you're a local or a tourist. Plus, Phoenix has nice wide streets. Most cities have one major road and a bunch of narrow streets that just can't handle heavy traffic. But Phoenix has wide roads everywhere. So, when the freeways get jammed, you can just hop onto a parallel street and still get to work without stressing out too much. When you look at all the job opportunities and the relatively smooth traffic, it's no wonder people are willing to put up with the heat and move to Phoenix. But don't get it twisted, the heat is no joke. It is really, really hot and sunny out there. We're talking about 300 days of sunshine on average, or about 85% daylight hours per year. But once again, Phoenix has made the best of it. And all that constant sunshine has turned Phoenix into one of the top solar energy cities in the country. Now, you may be wondering, a city in the middle of the desert with barely any rain, do they actually have enough water? Well, they do. Phoenix has its water situation pretty well sorted out, thanks to multiple sources. I mean, they don't rely on rain alone, which is a good thing because, desert life. Most of their water comes from way up north and east of the valley, where snow melts off the mountains and flows into giant reservoirs, storing it up for those dry years. But most of Phoenix's water comes from the Salt River Project, which brings water through canals and pipelines from the Salt and Verde rivers. Then there is the Central Arizona Project, which transports water all the way from the Colorado River. They even get a bit of water from underground wells. And Phoenix doesn't want to waste a drop, so they're smart about recycling, reusing treated water to keep parks green, and even recharging their groundwater. Since Phoenix is all about sunny skies nearly every day of the year, it's normal that people can get a little moody when it actually rains. But here's the thing. Phoenix always gets a surprise up its sleeve, even when it comes to bad weather. When it rains in the deserts, locals get treated to this unique earthy smell. It's thanks to the creosote bush, a desert plant that releases an amazing fragrance when the rain hits it. People describe it as the smell of rain, and honestly, it's one of those fresh, clean scents that makes you forget you're in the desert for a second. And if you've never stopped to think about why Phoenix is called Phoenix, well, it's based on that famous legend of the bird that rises from the ashes. Now, after knowing all the special things about this city and its unique ability to turn challenges into advantages, we can say the name couldn't have been better chosen.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher, though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered, so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
So get this. Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the New Year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Dateline would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Dateline look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international dateline that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international dateline was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international dateline didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international dateline. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the dateline. Suddenly, Kiribati was straddling the international dateline. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the dateline moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international dateline, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international dateline looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of standard time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the daylight savings time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone, just like the United States, which has 11 time zones. Australia has 9, while India Well, India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have one. This means that the sun rises almost 90 minutes earlier in Dong in the far east than in Gujarmoti in the west. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not? Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They look like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia Subduction Zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia Subduction Zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau Volcanic Zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with irregular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship, the big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next to water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under ½ an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses. How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the North and South Pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans and you get a geoid. In reality, the line stretches across oceans as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano. On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is.
The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's gonna be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Ediacaran fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600, before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now It could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as tsunami ready by UNESCO doesn't mean a community is tsunami proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos.